We present you a video presentation of the report for the Second International Conference on Sustainable Futures, Environmental, Technological, Social and Economic Matters. Technological measures to enhance efficiency of mining or from stopes. Applying self-propelled equipment. The research aims to study and enhance basic stoping processes, develop technological measures to increase efficiency of mining or from stopes applying self-propelled equipment. To reach the set objective, the following methods are used. Analysis and study of underground operations with applied self-propelled equipment. Enhancement of drilling and blasting operations applying self-propelled equipment. Development of efficient structures of the draw level when applying load haul machines. Enhancement of stoping methods and technologies when applying self-propelled equipment at Krivba's underground mines. Let us select and substantiate rational stoping parameters at the Oktyabrskaya, the PJSC-KZRK. Considering mining and geological conditions of the ore body Osnovnyi, physical and mechanical properties of ore in country rock, the sublevel Enrum mining system is accepted for mining the ore body Osnovnyi of the Oktyabrskaya minefield. Ore breaking is performed by vertical blast hole rings on the vertical slot. The sublevel Enrum mining system is designed for use of self-propelled mining machinery. The input data for calculating block geometry are given in Table 1. We determine geometric parameters of the mining system. Dimensions of the stope along the strike are calculated applying the found value and the known value of the horizontal thickness. Dimensions of the stope to the dip are calculated applying the found value and the known value of the normal thickness. The obtained dimensions of the constructive elements of the system are given in Table 2. For drilling, it is expedient to use self-propelled long-hole drilling machines. Simba of Atlas Copco. The massif is broken by vertical blast hole rings on the horizontal compensation. Space, trench undercut, Fig. 1. Drilling and blasting parameters for mining a block with average or hardness F equals 6 are given in Table 3. The blasting and drilling parameters are calculated based on the practice of the underground mine Oktyabrskaya. The line of least resistance equals 3 meters. The distance between hole ends is 3.5 meters. In our opinion, such parameters will decrease oversize yield and losses of explosives for secondary fragmentation. Two versions of the rational draw level structure are suggested. The first version of the draw level with application of modern load haul machines for transporting broken or is developed for the ore body thickness L of over 25 to 30 meters, Fig. 2. Block undercutting is trench. The trench 5 is created on the transportation level across the strike. The main disadvantage of loading broken or from loading faces driven at the angle is that the bucket goes into the broken or at the angle as well, thus deteriorating the bucket fill factor and resulting in one side wear of the bucket. To eliminate this disadvantage, we suggest formation of the loading face 6 in the way that enables frontal fill of the bucket through its entering the muck pile perpendicularly. Other option of the draw level with application of modern load haul machines for transporting the broken, or is developed for the ore body thickness L of less than 25 to 30 meters, Fig. 3. In this case, the stope 2 is located along the strike. Block undercutting is trench. The trench 3 is created along the strike for the full width of the stope. The work presents analysis of literature sources dealing with application of self-propelled machinery in stoping in general and for underground mining operations only, and considers practices of mining enterprises' performance in similar conditions. Geometry of block elements at stoping, applying the sub-level ANRUM system in compliance with the instructions, determination and control of permissible dimensions of structural elements of mining systems at Krivba's mines is calculated to ensure stability of stopes throughout the block life. The article suggests efficient versions of drilling the massif and determines their advantages and disadvantages. The main disadvantage of loading the broken or from loading faces driven at the angle is that the bucket of the machine enters the muck pile at the angle as well, thus deteriorating the bucket fill factor and resulting in one side wear of the bucket. To eliminate this disadvantage, the authors suggest new versions of the draw level. Structure with formation of the loading face in the way that enables frontal fill of the bucket through its entering the muck pile perpendicularly, and provide drawings of the versions. The suggested enhanced technology of stoping considers the recommended parameters of underground operations on the basis of the research conducted. The conducted research proves the viability of the developed technology and enable recommending its implementation.